Whatever we have done so far regarding the action of the force, the first one was that it can change the motion of an object. The second one was it can change the shape of an object in the chapter of deformation. The third one was that it can cause a change of direction, which was centripetal force or circular motion or something like that. The fourth factor that a force can do is produce a rotation or a rotatory motion. Let's look at that. So let's say that we have a rod like this and it's standing on a system of pivots like this, much like a seesaw, right? So we have two masses, for example, on both sides. If there was one mass was missing right now, what do you reckon is going to happen? It's going to rotate in this direction, right? So eventually the rod may look like this to you with the mass being placed over here. Yes? Okay, so to balance this out, we have placed another object over here, and let's say that the rod or this point is stationary for now, or it is balanced. So the moments or the principle of moments or simply moments is can be found by the product of force multiplied by distance. Now this distance is very necessary to understand what type of distance. If you remember, we have done the same formula for work done. That is force multiplied by distance. This is also force multiplied by distance, but there is a difference between them. In work done, the object has to move in the same direction. Yeah. So over here, if I want to figure out the force vector, then that would be the weight of each of the mass. Let's say if this is mass 1 and this is mass 2, then this would be force 1, which is of course the weight of the object, eventually found by using the formula mg. Over here, this one would be force 2, which is the weight of the object, which will be found by mass 2g. This is mass 1g. Now, when it's about finding the distance of these respective forces to find the moment, we're supposed to take the distance from the point or the center of gravity to the pivot. Pivot is the point that is for a system going to stay stationary for that current situation. It will not lose its position, it will not move from its position, it will stay at that same point while the rest of the system rotates or moves, right? So the distance is taken from the center of gravity of that mass to the pivot. Or if it's a simple action of a force, for example, then this could have been like this. A pivot system like this and a force acting like this. Then this would be from the point of action of force to the pivot, similarly from this point to this point. So these are their respective distances. So this will be labeled as D1 and this will be labeled as D2. So if the examiner says that this rod is balanced or is in equilibrium, then we would say, or then we can use the principle of moments. Now the principle of moments suggests that clockwise moment should be equal to anti-clockwise moment. What is the clockwise and anti-clockwise moment over here? We just refer to the example of the motion of the clock. So if I look at M1, this would be causing a rotation in this direction. So I will call this anti-clockwise. This mass would eventually be causing a rotation in this direction eventually, and I will be calling this clockwise, right? So what this moment or what this formula tries to tell us is that if you know for a fact that this is in balanced condition or in equilibrium condition, then both moments should be equal irrespective of their individual values. So right now, if I want to find out the moment over here, that would be force 1 into distance 1 equals to force 2 into distance 2. So this one would become m1g multiplied by d1. This one would become m2g multiplied by d2. And when I replace the values, I can find out that both will be equal. But there's one thing that the examiner does is that he misses or he omits one value and asks you to find it. So let's say that the values are given to us as this is, let's say, 2 meters, this is 5 meters. The mass given to you is 2 kg. You need to find m2. So what would you have done? Simply apply the formula, that is m1g d1 equals to m2g d2. One interesting thing about this is that the value of g can be cancelled out. It is not required for this question. Why? Because the whole system exists on the same planet. So whatever mass, whatever force it is exerting, that would have the same value of g for both sides. So we are only left with mass into d. That would become 2 into 2 equals to, all right. Okay. So this is our circular, this is our rotation, this is our principle of moments, and let's try to incorporate a solved example into this. Let's say this is our pivot. There are many forces acting on the system, and need to find out the force that may be missing in this question. Let's say that this is 100 newtons, this is 70 newtons, this is, okay, just let's create a disturbing factor over here. This is 50 newtons, and let's say this is the force that you want to find out, and this is 20 newtons, and all the distances are given to you, but with a slight challenge. Okay, so this is 0.2 meters, this is 0.1 meters, this is 0.5 meters, this is 0.1 meters, and this is also 0.1 meters. So if I ask you to make the equation thinking that this rod is balanced, so how would you make that equation? What would that equation be? I want you to find out the value of F. Yes. No, this is not how we are looking at the question. Every force is independent. Just because you feel that it's adding with someone else doesn't mean that it's going to be added directly. You have to add the moments. If I go back to this equation, this is a simple equation for moments. We cannot say that if there is another force, it will be added with this force and then it's going to act. No, this is not the way. We will think about it in terms of moments. So if I had to make this equation, I would be looking at the center line to be the pivot. This is where my equality or equation Now just please listen to me, okay? Do not interrupt me. Okay, so this is where the line or the central line is going to be. So when I want to find out the moment of every single factor, I'm only looking forward to the force and distance factor. Okay, so what is the moment of this one, then so on and so forth. First thing that I need to do is figure out what forces are helping each other. So I understand that the 70 newtons and 100 newton are forces that are helping each other. We will not add them together directly, but we will add their moments, not the forces. So if I look at this 20 Newton, I realize that it's trying to rotate the rod in the same direction as the 170 Newton, even if it's placed somewhere else. It's trying to rotate it in the anti-clockwise direction. And the 50 and F are trying to rotate this into the clockwise direction. So I will bring everyone or every anti-clockwise factor on one side and every clockwise factor on the other side. So this will become 100. Now, students sometimes get confused that maybe this is the distance. No, the distance has to be from the point of action of force up to the pivot. So it's your job to add both distances because you have to go from this point to the pivot. So one confusion that the examiner sometimes gives you. So I'm just adding it directly, so that's become 0.3 plus. Now I will add the 70 newtons moment, not the force. So 70, its own distance from the pivot is 0.1, that is going to be this one, plus this 20 newtons factor that is actually also helping them, right? So 20 and its own distance from the pivot. So that is 0.5 plus 0.1, 0.6. So this will become 0.6. And on the other side of the system, after the equality, if I see from this pivot, I have an equal sign, and on this side of the equation, I have 50 and 0.5 plus. So once I'm done with one force and its distance product, the next step that I have to do is add the other factor that is helping it. What's the other factor? That is F. So F, which I don't know what I want to find out, and its distance from the pivot, the total distance. So that will become 0.7. Now, once you solve this whole equation algebraically, right, you will find the value of F. And for the sake of example, if you've done this, then so right. If you haven't, then let me give you an example. Let's say that the value comes out as 45 newtons. It's not a calculated value. I'm just trying to give you this as an example. That if this was the answer, then what does that mean? It means that this force F needs to be 45 newtons in terms of its magnitude and strength for this rod to be balanced in its own position. Do we understand up to this point? Right? Okay, so this is our moment, and to give you real life examples of the moment, it is as simple as, let's say, opening a door. This is the door, let's say. So what you've done is opened a door. This is the handle of the door. So how have you done that? And this is the hinge of the door. These are the hinges of the door where the door is connected to the wall. So in this case, they are acting as the pivot of the system because they are not moving from their position throughout the motion of this door, right? Over here, if you look at the seesaw example, this is acting as my pivot because even if the rod balances towards this side or it balances towards this side, whatever side it balances on, the location of the pivot is not changing. So pivot does not participate, it only helps solve the question. Over here, the hinges of the door become the pivot. Why am I discussing this? Because it's your job as a student to figure out right then and there in the question that what would be the pivot for that system. Now let's say that if there is a person doing push-ups, for example, and these are their feet, these are his feet, for example, touching the ground, and this is his arm trying to push up the ground, right? So these are the feet and these are the arms Can you identify what would be the pivot of this system? And this is its head, for example. So he's doing push-ups, for example. So what would be the pivot of this system? The feet will be the pivot because they did not leave their position as the person tries to push itself upwards. What he has done is move from this position to this position, right? So we will consider the feet to be the pivot. Similarly, if I look at the door of my fridge, then the hinges will be the pivot. Similarly, if I had a deep freezer fridge like this one, and if I wanted to open this door, if the door is open like this, then this whole line, this whole point would have acted as the pivot. And when you are applying a force upwards to open the door, the weight of the door would be acting as the counteracting moment. Do we understand the situation for the pivot and the application of force? Right? We understand this. Okay. So any problems up to this point? All right. So the next